Hey, how are you? Last class, we stopped here, mathematical method of aggregate planning. If demand is 800, March, April 1000, May 750, then regular time capacity is 700 each month. And then if the company use overtime, 50, 50, 50, and subcontracting using then 150, 150, 130 additional. And beginning inventory is 100. And then cost here, if we use in regular time, then $40 per tire or item. Overtime, $50, about $10 higher. And subcontracting using subcontractors, then $70. And then carrying cost, if there is an inventory carryover, then $2. Then we can use Excel to solve this problem using a function and so on. Then after input all required data or information, then using solver, Excel solver, then this one is typically transportation method, similar to assignment method. So match capacity and demand, and how can we allocate? So match assignment method match one by one, but this transportation method match demand and then supply. Okay, this one just to show you, I will ask you do this. Any like a quiz or final, but future reference. If you are interested, then find the file on Moodle, example file, this one. Then if you want, then you can do together or just watch how it works. Okay, I will give you time if you are interested, and if you want to do together, give you time to download and then open this file. Excuse me. Okay. By the way, I graded your quiz number 2. Some of you miss the quiz. Anyway, improved. So the average score improved from last one. So instead of now giving new assignment, give you quiz that work. So anyway, I appreciate your efforts. Okay, let's do it. So here are information. So to run this, we needed information data. So this is kind of cost table. So if use regular time production, then $40, $50, $70, and carrying cost $2. So type in 40, 50, and 70, and $2. And then this table, this one also kind of cost table. So beginning inventory. If there is beginning inventory, then the cost is $0. Then if produced in March, then carry over to April, then $2 here. So we can just type in $2, or we can use this kind of formula function equals earlier one plus $2. Then if this class is like a management science or analytic course, then I explain more detail. But we will use this cell again and again. So make this cell C8, make it absolute value. So using F4 function, then we can change like this. $sign with the $sign, the cell number, and this one using again and again, even it goes to move the cell. So enter $2. Then I can copy this cell to this way, and automatically this one calculate like this. And then regular time, if produced in March and then use in March, then $40, $50 over time, and then use subcontract $70. Then produce this one in March, then $40, but carry over $2 increase. So this one will be equals earlier one plus this cell $2. So enter, then move this one, copy this one, then automatically $4 add, and then just copy down, and oops, this one also change this. Okay, this one also making an absolute value. Enter, and copy like this. And then this one also make it absolute. Enter. Not that one. Not this one change plus this one absolute. Enter, and copy down, and same. And here again $40, $50, and $70. So produce in April and then use in April, same as March. And then here equals plus this one plus. Actually use this one, and then absolute enter. Okay. Then this one, just copy. I will copy this one, and then so like this. And then if there is capacity, but if they don't use, then it will be $0. So 0, copy down. And then this section is like not possible, not feasible. Produce in April, use in March. This is not possible. So that case, give like a big number. Give a big number, 999, like this. Then this system, this program will not assign that not feasible cell. And next part about the demand and then supply capacity. So beginning inventory, it says 100 now. Then regular time, we don't know. This one, not we don't need this part because this one system assign. So here, total capacity beginning is now 100. Then from the given chart, regular time, March 750 and 150. So this section, 700 capacity, and 50 capacity, and 150 capacity. And then this part, 750, 150, the same. 750 and 150. Then next capacity, 750, 130. And this part, demand, total demand. The total demand is 800, 1,750. So 800, 1,750. And then this unused capacity, the total capacity minus total demand. So this cell will be equals total capacity. That is, I will use the function sum of total capacity minus sum of total demand. Okay. So 230 will not be used because the capacity, total capacity is now more than total demand. And then this cell, this transportation method, this cell add or, then that add or, and then this cell is add this column, this column, this column, this column, something like that. So here equals sum of this row, enter, then we can copy down all the way, and then this cell, same, equals sum of this column, enter. Then this cell, just copy like this. And then this cost cell. So using this cost, produce in March and then use in March, produce in March, use in April, and so on like that. So total cost will be this sales cost, and then how many produce in this cells. So that will be this one times this one. So this area times this area. In that case, we can use function sum product. So using this, and then this one ask range, comma, so this range, and plus parentheses, this is. So this means this one times this one, this one times this one, and so on, then add all, so there is no sum product, enter. This time, this one is not assigned yet, so cost is 0. So prepare like this, data and then functions, and then we can use solver. You may not have this solver menu button in under the data tab. In that case, you can add that add-ins. So click File, then Options, and add-ins. Go, then find the solver. And your Excel has no solver, but maybe this one unchecked. So if you check this one, then it will be available. So open solver. This box asking objective, there is no this cell. So objective of this cell is like minimize total cost. So we need a cell, this one, so click this one. And then this problem is minimize cost problem, so minimize, min. Then changing variable cells, that is assignment, how many produce. So changing variable cell will be here. So specify the cell. And then this part is constraint. So constraint is like this. Add or this row, then it will be this one, and then this one will be less than this capacity. So I will do that. So add. So this cell, we can do it now one by one, but we can do it all of them. And less than this sign, then constraint this part, then okay. And then next constraint, add all, this cell is add all this column, and then this one should be less than or equal to. So those cells less than or equal to and then this cell, and okay. Now we are ready, and then we will use the simplex LP linear programming tool, and click solve. Let me see. Oops, something wrong. It's not assigned. Why is now like this? Why? Maybe I missed something. Okay, cancel. Do it again. Why? Maybe sign is change equal sign. It should be match. And then change. Minimize, okay. And then, yes, got it. So this case, this problem, to minimize cost, produce, there is no 100 inventory carryover, and then 650 using regular time in March, and then overtime 50, and then in March, produce 50 more, then 50 use a contractor. So to match demand, 800, 1,750, and 230. And then this cell match capacity. So the total cost will be $5,700. So using this kind of tool, you can solve this problem. But actually, this one is not part of the undergraduate operations management, but I just show you you can do it using this Excel and then Excel solver to solve this problem. Okay, do you have any question about this? Okay.
Did you say we aren't going to be like graded on this?
No. Just to show you for the in the future, you may involved in certain work. Then somebody asks you, do you know about the transportation method, or you know, aggregate planning using mathematical method. Actually, this part is an upper level. Marriott doesn't have that course, but some other school has management science or analytic course, and they cover this part. So you may go graduate school and so on, then you may have a chance to learn this part. So just to show you, so don't worry about that quiz or assignment or exam in this part. Okay, then next part. Make sure if you are on right screen. Chapter 9, Material Requirement Planning. Simply, we call this MRP system. MRP system is a means for determining the number of parts, components, and materials needed to produce a product. So this is a kind of a tool for the production planning. So MRP system provides time scheduling when and then how many material parts produce, and determines the date when orders for those materials should be released based on lead time. So earlier we talked about an inventory system, then how many place order, and then how when place order, like an reorder point, and then reorder time, and so on. So using this MRP system, run this like a program software, then we can determine how many parts, and then what kind of parts, and then when use and when place order. So purpose of using this MRP system is getting the right materials to the right place at the right time. And then using this one, then company can improve customer service, minimize cost, and make it operating system efficiently, make it better. And then based on dependent demand, I mentioned this one earlier. You know, parts and finished product, like a car, like a car. Car itself is a finished product, and then like tires, a part, and then finished product. So finished product is independent demand. Then parts, components, and so on, they are dependent demand. So based on independent demand, so if we know the schedule production plan, like 1,000 we need, then except the tire in a trunk, just a regular tire at 4. So dependent demand is like 1,000 times 4 equals 4,000. So based on independent demand, we can get how many dependent demand. So MRP system is based on like a part, component, and so on, material. And also MRP system is software, computer program. Still, many companies use this MRP system as a kind of module of the ERP system. By the way, you know, many, you know, ERP system, right? ERP system, enterprise resource planning. People say ERP system from MRP system. Between there, MRP MRP 2 systems. So MRP system, and then MRP2, and then ERP system. Difference is ERP and MRP2 system has integrated system, and then this one is kind of single system. That means MRP system used by maybe one department. So MRP system has like a database. But the ERP system and MRP system, there is no one database, and then this database used by many department and share one database, yeah, using by finance, accounting, and production, maybe MRP system, and so on. So many departments and then many different modules share one database. So we call this integrated system, and then MRP system is kind of single system. So people say MRP system to MRP2, and then ERP system like a progress like this. Okay, then. Okay, a kind of structure of MRP system. To run an MRP system, we need 3 basic required file. First one is MPS, master production schedule, and then bill of material, inventory code file. So using 3 kind of data or information, then we can run MRP system. Then after run MRP system, produce primary reports such as how many, when, what kind of part produce. Then if there is something change, then MRP system produce secondary report, exception reports. Demand change, then change the production schedule, then change such like that. And first, require the file, master production schedule, MPS. This one shows how many parts need to produce. This one is show how many finished products. Actually, this one is independent demand. And then this one from aggregate plan. So from aggregate plan, first month, second month, and so on. Then this one aggregate plan, disaggregate and detail schedule. So this is MPS. And bill of material, BOM. This one is kind of a structure of the final product and components. So based on this one, for example, final product A need 2 of the B components and 3 of C, and then B need 1 D part and then 4 of E part and so on. So when we develop this BOM, bill of material, use this method, low level coding. Before using a low-level coding, maybe the same part in different tier or level. Like here, R part in level 2, and then also in level 3. So this case, sometimes miscount, so make it error. So bring all of the same component parts to a single level of product completion. So same parts on the same place on the same level or tier. So N here, N here, then R, Q, Q, and so on. So using this now low level coding to make easy to compute total number of each part needed. So using this one, then reduce counter error. And the last required file, inventory record file. This one shows like if there is inventory on hand, and then if there is scheduled receipt already scheduled, and then when it will come there. So using three required files, then we can run MRP system. And then ordering policy, lot for lot and fixed lot. Lot for lot, if the company use this one, this method or policy for the like an inventory system, ordering system, then the ordering quantity will be different when they place order, because if required order is like 1,000, then currently the company has an inventory on hand like a 500, then 1,000 minus 500. So that is 1,000 minus 500 equals 500. That is the net requirement. So using that net requirement, order that many net requirements, and then fix it last size ordering system. We covered the EOQ model, fixed order quantity model in chapter 11. So using that method, then fix order lot size, then order that many again and again. Then other ordering policy, list total cost policy. The idea is like this. I don't know if you remember this one, total cost, and then on this lowest total cost quantity, then increase order quantity, and then decrease, and then increase. So this is lowest total cost point. On this point, carrying cost, and this one is order cost, the same. So increase order quantity, then difference between carrying cost and ordering cost, decrease. And then pass this point and then increase again. So using this idea, if first week 50 requires second week 60, 70, and so on. So order only 1 week amount 50. Then use that many. Then there will be no inventory carryover, so no carry cost. But place order one time, so some order cost. Then order 2 weeks amount, and use 50 and then 60 carryover, so some carrying cost. But the order cost is the same because order only one time. So difference between carrying costs and other cost, $47. And then here, $44, 47 minus 3. And then 47 minus 10, 37. 47 minus 19, then that will be 28. And 47 minus 38, that will be 9. And then 47 minus 56, that will be 11, 10 point. 10.25. Then here 27.75. So this difference decrease certain point 0 on this point 0 and then increase. We don't know when it is 0, but given order quantity, then the difference between carrying cost and other cost in smallest. So take this one, this order quantity. So if we use the list total cost method policy, then 335 order quantity is optimal order quantity. And next one, list unit cost. So add carrying cost and order cost. So that will be 47, 50, 57, 66, and so on. And then order quantity. So 47 divided by 50, that is unit cost. And this cost divided by order quantity, 0.4545. So among those unit cost, smallest is this one. So take this order quantity. So if we use list unit cost policy, then 410 order quantity is optimal order quantity. Okay, example. You know, this one will be question of quiz number 2, 3, 4. Yeah, 4. So listen carefully. Example, first required master product schedule, MPS. So final product A need 800 in week 5 and again 800 in week 10. And bill of material, BOM, shows structure of final product A. A need 1B part, and then 3C part. Inventory record file. Final products currently 70 inventory on hand. And then lead time is 1 week. And there is no safety stock. And then already place order. So in week 2 and week 7, 50 will come. Then part B, there is no inventory on hand. 3 weeks of lead time. C, 1,000 on hand, 2 weeks of lead time. So this MRP system It's software, but I cannot show you the real one. Instead, just to show you how it works if we have that program software, then how it works. Okay, based on MPS 800 in week 5, 800 in week 10, and then based on inventory record file, 1 week of final product lead time on hand is 70, and B 3 weeks. No, there is no on hand. And then C 2 weeks of lead time, and then 1,000 on hand. So start final product. So 800 in week 5 and 800 week 10. Then schedule the receipt based on this inventory file, 50 in week 2 and 7. So 50 will come in week 2, schedule the receipt, and 50 in week 7. And then projected available balance, because now 70 available, so initial inventory is 70. Then week 2, add 50 here, so 120 available. And then no change until this week. 800 need, but inventory on hand, available inventory is 120. So net requirement is 800 minus 120. So 680 is net requirement. So to satisfy that requirement, we should receive that many. If we use lot for lot ordering system, then order lot is the same as net requirement. So net requirement, we should receive that many net requirement. And then 1 week lead time. So it should be placed order 1 week earlier. And then to satisfy this final product A, we need part B and part C. So to make 680 final product, we need 1B and 3C. So to make 680 final product, we need 680 part B in the same week. And then times 3, then 2040 part C. And then part B, there is no inventory on hand. So 0, 0, 0, 0. Net requirement 680. 680 need, but 0 available. So net requirement is 680. So we should receive 680 at the same time. To receive this one, we should place order 3 weeks earlier. And next part C, 1,000 on hand, so available 1,000 up to this point. So net requirement 1040, then 2 weeks. earlier. And then the same after this point, 800 need, available 120, received 680. So total 800. So need 800, available 800. So after this point, 0 inventory. Then 50 receive, then 50 available up to this point, 750 net requirement because you use lot for lot, and 750 receive, order 1 week earlier. Then the same 1B, so same number times 3 for C, then 0 inventory, and so on and so on. So far, we talked about if we use lot for lot policy, looks like this. And then one more, if we use fixed lot order size in the system, then the same 70 available, 1 week, 3 weeks, 0 available, 1,000, 2 weeks. And then just assume if we use like economic order quantity model and then find the order quantity, economic order quantity, if we later the same up to this point use this final product using lot for lot, and then up to this point the same. Then if we use fixed lot size, then we assume if 900 order quantity is economic order quantity or optimal order quantity for part B, and then the 2000 for the C, then even if net requirement is 680, because optimal order quantity is fixed, so place order this many, so order that many 3 weeks earlier, and then 2000 fix it. So even if this net requirement is 1040, just order optimal order quantity 2 weeks earlier. And then look at this. 680 need, but net requirement is 680, but order 900. So 900 receive, then use 680. So there is carryover 900 minus 600 because it used fixed dot order system. Then 220 carry over up to this point. Net requirement is now 530 because 750 need but 220 available. Net requirement this one, but order 900 because it is fixed. And then after this point, 900 minus 530, so carry over this many. And then here the same. 1040 need, but receive 2000, so 960 carry over, and so on up to this point. And then net requirement is 1290, but receive 2000, so 2000 minus 1290, so 710 carry over. So compared to policy or order system, if we use lot for lot, then inventory may be 0 like this, but order quantity different. If we use fixed lot ordering system, Then order quantity for the item or part the same every time. So we don't need determine how many order again. We don't need, but that maybe there is inventory like this, the same. So, but we cannot say which policy ordering the system is better, depending on what kind of product, what kind of part, and then economic condition and so on. So anyway, two systems are different like this. Okay, that's all for today's lecture. And next Monday, I will give you practice problem and then the previous quiz question. I will review 2 questions. Okay, that's all. Any question? Okay, if you don't have, yes.
No, it's just me, David. I'm just we're
Okay,
still on.
okay, I know.
Right? Okay.
Okay, if you don't have a question, you can leave. And then if you want to, if you missed the quiz number 2, and then if you want to make it, then stay, and then or just say bye.
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 Bye, thank you.
Thank you.
Bye, sir.
Thank you.